This video is brought to you by thepuzzler.com. Welcome to the first class in our AMC 8 bootcamp. In today's class, we'll be looking at ratios, percents, distance equals rate times time, and tons of practice AMC 8 problems. Homework for today's class will be available at thepuzzler.com/AMC-8-bootcamp. Let's start with today's class. At any time during the class, you can ask any questions or answer any of the questions on the screen using the chat feature.
Hello everyone. Okay, I hope everyone can hear me right now. Well, hi everyone. We're going to be starting with a quick review of ratios, looking at some problems, and then we'll look at distance equals rate times time problems. Just to confirm in the chat, let me know, can you hear me? Can everyone hear me in the chat? Yes, I see some yeses. Okay, that looks good. Then we'll start. Okay, people can hear me. We'll start. So we'll start out really basic. I know most of us know what ratios are, but we need this to know what fundamentals are, right, when we're looking at further AMC 8 problems. So ratios are just a way of describing the relationship between two numbers. And the ratio of A to B is just simply A over B. For example, here I have 3 orange rectangles and 2 blue rectangles. Now there's a few different ways that I can write this ratio. I can write the ratio as 3:2, right? First element to second element. Or I could write it as 3:2 using the word TO. Or I can write it out in words. So 3 orange rectangles to 2 blue rectangles. But the most common way is fractions. 3/2. And the reason why this is the most common is because you can use fractions to do a lot of mathematical items, like simplifying the ratio. But you might also see the ratio with the colons a lot. And the reason for that is because we use that when we have more than 2 elements in the ratio. Let's move on. So why are ratios so useful? Well, we can scale ratios, and that's very, very useful, as we'll see later on. This is the same ratio as before, 3:2. But what I did was I doubled each element. So now instead of having 3 orange rectangles, I have twice the number of orange rectangles. I have 6 orange rectangles. And instead of having 2 blue rectangles, I have 4 blue rectangles. And that sort of doubled my ratio. Now, you might not get why 6:4 turns into 3:2. And let's see why it does. This is very basic. We'll look at advanced stuff as we move on. If you write it in fraction format, it becomes clear. Both the top and the bottom have a factor of 2, so it cancels out to be 3/2, which gives us our ratio. And in fact, if you have any ratio A to B, where A and B are some numbers, you can scale this ratio by multiplying both A and B by any number x, where x isn't 0. So we get A over B is equal to A times x over B times x. Those are the same ratios. Okay, so the trick with ratios is to just always multiply or divide the numbers by the same value. For example, if I have 6 apples and 8 oranges, what is the ratio of the amount of apples I have to the number of oranges that I have? I'll give you guys about 30 seconds. This problem is really basic in terms of ratios, but we'll look at harder problems. Just want to see everyone have a solid grasp of this. Okay, so what we do here is, let's see how to solve this one. We take this, write it in fraction format so that we can simplify. We have 6 apples to 8 oranges, 6/8. Now both the top, so let me write that more clear, 6/8. Now both the top and the bottom have a common factor of 2. Let's clear that out. This is equal to 3 and this is equal to 4. This is the equivalent ratio 3:4, We can't simplify this further because the numerator and denominator don't have a common factor. You could still divide by other numbers. You would just have fractions in the numerator and denominator, and no one wants that. Let's continue. This time, I have 6 apples and 8 oranges like last time, but now my sister gives me 9 peaches. What is the ratio of the number of apples I have to the number of oranges I have to the number of peaches that I have? We do this problem just like last time. We write 6 over 8 over 9. But we can't do this. This isn't allowed. This isn't even a valid fraction. A fraction can only have a top and a bottom. Most people, when they read this, they're probably going to think you're referring to 6 over 8 over 9, which is something that's completely different from the ratio we're trying to say. So what do we do here? We use the colons. How do we do that? We write 6 to 8 to 9. 6 to 8 to 9. Now you might be wondering, okay, the 6 and the 8 have a common factor of 2, so can't I simplify that? Well, unfortunately, you cannot do that because a 9 doesn't have a common factor of 2. So whenever you're simplifying a ratio, you need to make sure that all elements of the ratio have that factor for you to simplify. It's not enough for just 2 of them to have it. Okay. So that's enough easy theory. Let's move on to some AMC 8 problems, right? What you'll see on the actual test. We'll start with a problem number 1. I think this is the only number 1 that we're going to be doing. An amusement park has a collection of scale models with ratio 1 to 20. Let's underline that. That's going to be important. Of buildings and other sites from around the country. For example, the height of the United States Capitol is 289 feet. Can you find the height in feet of its replica to the nearest whole number? So for example, if we have something that's 20 feet tall in real life, in this model, it's only going to be 1 foot tall. And this is going to show us how to solve ratios. I'm going to give you guys 60 seconds to try this problem on your own. Feel free to write your answer in the chat. Oh, I didn't realize I was muted. Okay, so what we're doing here is we have to realize that we have this ratio, right? Let me redo this. We have this ratio. Let's erase a bit. We have this ratio 1 over 20 is equal to x over 289. How did I get that x? Well, remember that this 1 to 20 ratio is always going to be true for any model in this building, right? In this diagram. Now the capital is 289. So the height of the replica is supposed to be the number that we're trying to find. We don't know what that number is, so we're just going to call it x. Okay. Now here we apply something called cross multiplying. What we do is we multiply by the denominators of both sides, right? In essence, cross multiplying is multiplying 20 times x and then multiplying 1 times 289. That's what cross multiplying is, and that would give us the answer. But here what we're just going to do is we're going to multiply both sides by 289. 289 cancels here, and we also have to multiply on this side, and we're left with 289 over 20 is equal to x. Making sense so far? Okay, so 289 over 20 is equal to 14 plus 9 over 20, right? You might realize that 20 goes into 280, whatever you did, but 9 over 20 is going to be the extra leftover. And this is equal to the value of x. Now, always reread the question to see what you're answering is the right thing. For example, we see that the height in feet of its replica, we're trying to find that to the nearest whole number. And that's very important. Our answer is not going to be 14 plus 9 over 20. Our answer is going to be this number rounded. Well, 9 over 20 is less than 1/2, right? Because 10 over 20 would be 1/2. So this would round down. And our answer would just be 14 feet. Let's move on the ladder. This time we're looking at a problem number 6. If the degree measures of the angles of a triangle are in the ratio 3 to 3 to 4, what is the degree measure of the largest angle of the triangle? Take 60 seconds, try this problem. Okay, let's look at this problem. First of all, how many degrees do we have in a triangle? And this is something that you must know for the AMC 8. We have 180 degrees in a triangle. 180 degrees in a triangle. Now our ratio is 3 to 3 to 4. Our ratio is 3 to 3 to 4. Imagine that a triangle only had 10 degrees in total. If a triangle only had 10 degrees in total, what could we do? Well, we could say 3 plus 3 plus 4, so the elements of the ratio add up to 10. So then our first angle could be 3 degrees, our second angle could be 3 degrees, and our third angle could be 4 degrees. And that's it, we got our 3 angles, and that would solve our problem. Unfortunately, they don't add up to, the number of degrees in a triangle is not 10 degrees. So what we do is we scale our ratio. Now we have to find by what factor should we scale it so that the sum of the 3 angles is equal to 180. Well, we don't know what that scale factor is, so once again, if you don't know what it is, use a variable for it. This ratio is the same as 3x to 3x to 4x for any non-zero value of x. Now the sum of our 3 angles, 3x, 3x, and 4x is 10x. And the sum of the angles in a triangle is equal to 180. Okay, so now we divide both sides by 10 to get x equals 18. If x is equal to 18, we can plug that back into our ratio. So we have 3x to 3x to 4x. We get 3 times 18 to 3 times 18 to 4 times 18. 3 times 18 gives us 54 to 54 to 72. Okay, just quickly checking our angles. 54 plus 54, that gives us 108. 108 plus 72 gives us 180. So we're extra sure that we're correct. So our three angles are 54, 54, and 72. And now we reread the problem. It's asking us for the degree measure of the largest angle. The largest angle is 72 degrees. So our answer for this problem is 72 degrees. Okay. Now I'm going to take a break from AMC 8. Let's look at a problem from the OEMC. Lily is making lollipop syrup. She needs to make the mixture by mixing lollipops and hot water in a ratio of 2 to 1. She has 50 cups of lollipops and 19 cups of water. Lily makes the maximum number of cups of lollipop syrup. How many cups of lollipops must she get rid of? Try this problem on your own. Write your answer in the chat with an explanation if you want. Okay, let's try solving this problem. So first of all, they tell us that we're going to have some cups of lollipop left over, right? So that might be a hint to us, right? That the lollipops, there's a lot of lollipops. And when we try our ratios, we're going to have some cups of lollipop left. Let's see. Our ratio of lollipops to hot water is 2 to 1. Now, our ratio for the number of lollipops that we have to the number of water is something that we don't know, right? We don't know the number of lollipops that we'll actually use. Let's say we use all 50 cups of lollipops. All 50 cups of lollipops. And then how many cups of water would we need? Let's say we use X cups of water. Cross multiplying, so multiplying both sides by X, we get 2X is equal to 50. Or X is equal to 25. But that's way too many cups of water. Which makes sense, right? We know that we have extra lollipops, so we can't use all of the lollipops. So maybe the number of cups of water is when we need to look at. Our ratio is 2 to 1, and this is equal to, we don't know how many cups of lollipop we need, X over 19. Multiply both sides by 19 to get 38 over 1 is equal to X. That's just 38 is equal to X. So that means that we need 38 cups of lollipop. Well, if you write 38 as the answer to this problem, you would be completely wrong. Remember to reread the question. How many cups of lollipops must she get rid of? Well, there's 50 cups of lollipops, and she's used 38. So now it's simple to note that 50 minus 38 tells us that we would have 12 cups of lollipop left over. 12 is our final answer for this problem. Let's go back to the AMC 8. There are 270 students at Colfax Middle School, where the ratio of boys to girls is 5 to 4. There are 180 students at Winthrop Middle School, where the ratio of boys to girls is 4 to 5. The two schools hold a dance and all students from both schools attend. What fraction of the students at the dance are girls? I'll give you 60 seconds to try this problem. It's not as easy as all the ones that we've done so far. By the way, if you haven't yet subscribed to our channel, make sure you do that. That way for future classes and for future courses that we host, you'll be the first one to know, and just do it. Okay, let's see how we would solve this problem. What we do here is we look at the number of boys at Colfax Middle School and the number of girls at Colfax Middle School. And we do the same thing for Winthrop Middle School, and then we combine our numbers. Okay. The number of boys, how many students are there in total, right? If there's 5 boys and 4 girls, then the number of students in total is 9. So 5 nines, if there's 9 students. I know there's 270 students, but since the elements in our ratio add up to 9, let's use 9. If there were 9 students, 5 of them would be boys, or 5 ninths of them would be boys, and 4 ninths of them would be girls. And the way I got that is the number of boys is 5 out of 4, so 5 to 4. So the number of boys to the number of total students is 5 to 5 plus 4, or 5 over 9. So the number of boys is this ratio, right? 5 to 9. Now this is equal to the number of total students we know is 270, and the number of boys is x. We can multiply both sides by 270 to get 5 over 9 times 270 is equal to x. 270 over 9 gives us 30, or that x equals 150. So notice a pattern here, right? Whenever we have a ratio and our ratio is something, let's say a to b, and then we have to solve the ratio again and find the value of x to c, you can just multiply both sides by c to get a times c over b, right? We don't have to do the full setup every time once we get used to this. But okay, so we know that there's 150 boys. Well, the rest of the students are girls, right? And there's 270 students, so you don't even need to set up ratios. We know that 270 minus 150 will give us 120. So there's 150 boys, I'm going to write that here, 150 boys and 120 girls. Okay, let's look at the next middle school. Here we have boys to girls in the ratio of 4 to 5, so it's reversed this time. So the number of boys is 4 ninths and the number of girls is 5 ninths. Using what we just learned about a over b times c, we know that the number of boys is 4 ninths times 180, which gives us 180 over 9 is 20, so 80 boys. 180 minus 80 gives us 100, so there's 100 girls. So let's write that here. 80 boys, 100 girls. This gives us what? This gives us 230 boys and 220 girls. Okay, so what do we, oops, that number is not correct. So we have 220 girls. Okay, let's just quickly erase that. Okay, so now we're just going to quickly double check that all our numbers are correct, and then we can combine our total data, right? So let's see. In total, we have 450 boys and girls, right? If you add up the number of boys and girls that we have. 270 plus 180, that would give us 300 plus 70 plus 80, which is also 450. So it looks all correct so far. So the number of people that we have is 270 plus 180, or 450. And the number of people that are girls are 220. So the ratio of boys or girls to total number of people is 220 to 450. Now those zeros cancel out, and we're left with 22 over 45 as our final answer. Okay, that's great. Let's move on to the next problem. We're getting a bit harder now. A number of students from Fibonacci Middle School are taking part in a community service project. The ratio of 8th graders to 6th graders is 5 to 3, and the ratio of 8th graders to 7th graders is 8 to 5. What is the smallest number of students that could be participating in the project? So you want to make one common ratio here. That's the hint I'll give you. So try your best, and we'll meet after 60 seconds. Okay, so for this problem, let's see. So we have the ratio 8th graders to 6th graders is 5 to 3. Let me just quickly head here. Okay, the ratios is 5 to 3. Let's write that out. 5 to 3. And the ratio of 8th graders to 7th graders is 8 to 5. Right? So now what we want is the number of 8th graders, right? You can't compare the number of 6th graders when there's 5 8th graders and the number of 7th graders when you assume there's 8 7th graders. And you can't compare the 6th and 7th graders in that way, right? Because that's not fair. That's not how it's going to work out in real life. The number of 8th graders is going to be constant. So what do? We're trying to get these two terms of our ratio to be the same. Well, what if they were both multiplied by some number that made them the same? Well, I know both 5 and 8 are a common factor of the number 40, right? That's very useful. What if we multiplied both terms of this first ratio by 8 and both terms of this second ratio by 5? Let's try that. So 5 to 3, we multiply both terms by 8. We get 5 times 8 equals 3 times 8, or 40 to 24. And 8 to 5, we get 8 times 5 equals 5 times 5. This gives us 40 to 25. And now we can create a common ratio. The number of 8th graders is 40 to the number of 6th graders is 24, and to the number of 7th graders is 25. Now we can't simplify this ratio, right? Because all three elements of the set do not have any common factor. Two of them do. Any two of them do have common factors, except for 24 and 25, but not all three. So what we do here is nothing. The minimum amount of 8th graders that we could have is 40. The number of 7th graders that we could have at minimum is 25. And the number of 6th graders that we could have is 24. Add up all these numbers now. That would give us the minimum amount. 40 plus 24 plus 25. This gives us 89 as our answer. So our final answer for this problem is 89. Okay, so now we'll be looking at something special called a percent. And a percent is just a special type of ratio, which means per 100, right? So if I write something as 10%, what I'm really trying to say is that the ratio of something is 10 to 100. Now, mathematicians are super lazy, which is why they came up with the percent symbol. But percent problems can be pretty hard, and we'll take a look at a few AMC 8 problems to see what I'm talking about. Let's get started. Here's a problem number 14 from the 2017 AMC 8 test. Both Chloe and Zoe are both students in Mrs. Demeanor's math class. Last night, they each solved half of the problems in their homework assignment alone and then solved the other half together. I'm hoping they had permission, but I'm not sure. Chloe had correct answers to only 80% of the problems she solved alone. But overall, 88% of her answers were correct. Zoe had correct answers to 90% of the problems she solved alone. What was Zoe's overall percentage of correct answers? Try this problem on your own. You have 60 seconds starting now. Okay, let's try solving this problem. Okay, so Chloe and Zoe, they both did half their homework alone, half their homework together. So when you're dealing with percents, one thing that you can always do, and even in ratios in general, is assume one of the numbers, right? If they don't give you any specific numbers, only ratios and percents, you can assume something about the problems, right? For example, here we can assume the number of problem count. If it's all based in percentages, it doesn't matter if they did 1,000 problems or 100 problems. We should get the same correct answer. Here, I'm not going to do that because I want to show you how to generally solve these problems. But yes, you could assume the number of problems as 100 and easily solve the problem that way. Okay, we have Chloe had correct answers, so only 80% of the problems she solved alone. Let's say they both had X problems. So the problems that she solved alone is X over 2 since she solved half the problems alone. X over 2 times 80%. Don't multiply by 80. Multiply by 80%, which is 80 over 100 plus and overall she got 88 of her answers were correct. Okay, so here I don't know how many she got correct with Zoe. We'll have to check. We know that she did X over 2 problems with Zoe and she got Y% correct. Let's say Y% correct. So Y% is the number of problems that they solved together and got correct, the percent of problems. So Y% is just Y over 100. And what is this equal to? Well, they tell us it's 88% of our total overall answers were correct. This gives us 88 over 100 times what? Times X. Because the number of total problems is X, not X over 2. X. And now we have an equation with two variables. But we're just hoping that the X's either cancel out or don't matter. And let's see. Let's do some multiplying out. We get 80x plus xy over 200 is equal to 88x over 100. Now what? Now we notice that all of the answers, all of the terms have a common factor of x, and which is why we see that x doesn't even matter. The value of x doesn't actually matter. We just cancel out the x. All the terms have a factor of x, we cancel it out. So now we have a linear equation. Now we have 80 plus y over 200 is equal to 88 over 100. So now our ratio is 88 over 100, and then we're just solving for the unknown ratio. Cross multiply. First thing you want to do though is notice that both terms in the denominator have a factor of 100, so multiply both sides by 100. This side cancels out, and 100 over 200 just gives us 2. Now we cross multiply, so we get 80 plus y times 1, I'm not going to write that, is equal to 88 times 2. 88 times 2, that's equal to 176. So 80 plus y is equal to 176. So y is equal to 96%. So the number of problems that they solved together is 96%. Where do we get that? We put it here. Y% is equal to 96. Okay. Now Zoe had correct answers to 90% of the problems she solved alone. Now, once again, you could just assume there's 100 problems, right? Then you know that she got 90% of them, and then on the other half, you can use averages to figure out what she got correct. But we're going to use x again. 90 over 100 times half the problems she did alone. So x over 2. Plus, we don't know how much, or we do know how much she solved along with Chloe, which is 96%. So 96% over 100. 96 over 100 times x over 2. And this is equal to y over 100. Let's use a different variable. Let's use z over 100 times x. Once again, the value of x just cancels out from each term. We're left with 90 plus 96, which is 186, over 200 is equal to z over 100. Once again, factors of 100 cancel out, and we're left with 186. 186 over 2 equals z. More specifically, z is equal to 93%. Don't forget the percent sign. So our answer is 93%. Let's box that. And let's see. Let's look at our next problem. This one's a bit easier than the last one. But the 2019 AMC problem number 8. Gilda has a bag of marbles and she gives 20% of them to her friend Pedro. Then Gilda gives 10% of what is left to another friend, Ebony. Finally, Gilda gives 25% of what is now left in the bag to her brother, Jimmy. What percentage of her original bag of marbles does Gilda have left for herself? Take 60 seconds to try and solve this problem. Once again, you could actually assume the number of marbles that she had at the beginning and then just take a percentage of that, since it doesn't matter, since we're only dealing with percents. Okay, so originally for this problem, I was planning on using some variable x, but I feel like it'd be good to show you guys what we would do by just assuming, right? Let's assume Gilda had 100 marbles. She had 100 marbles, and 100 is a nice number to work with, right? Because at the end, when we have to take ratios, right? What percentage of her original bag of marbles does Gilda have left for herself? It's going to be super easy because, for example, if she has 50 marbles out of 100 in the beginning, that's just 50%. Let's see. So she gives 20% of her to her friend Pedro. If she gives 20% away, then she has 80% left over. Okay. Now, the number of marbles that she has left, she gives 10% of them away to another friend, Ebony. If she gives 10% of this number away, then she has 90% of this number left. Finally, she gives away 25%. Well, 25%, that's just 75% left for her, or 75 over 100. Okay, what percentage of her original bag of marbles does Gilda have left for herself? A lot of canceling happens, right? This cancels out with that. These zeros cancel out here. We're left with 3 over 4 because both of them have a factor of 25. And 4 cancels out here to give us 2. Okay, so we get 2 times 9 times 3. This is equal to 18 times 3, or 6 times 9, which is 54. She has 54 bags left out of 100. That's just 54%, right? That's how we would solve this problem. And the way you would do that is 54 over the original amount, which is 100. That's our ratio, and since it's a percent, you multiply by 100. So we get 54% as our final answer. You would have gotten the same thing if you used some variable x instead of 100. Let's try the next problem. Okay, not as easy as the previous ones, probably the hardest ratio problem that we're going to cover so far. 2007 AMC 8, problem number 20. Before district play, the Unicorns had won 45% of their basketball games. During district play, they won 6 more games and lost 2 to finish the season having won half their games. How many games did the Unicorns play in all? Now 60 seconds might not be enough for this problem, but still I want you guys to try your best to see what you can do in 60 seconds, and then we'll look at how to solve this problem. Okay, let's see how to do this problem right here. So the Unicorns had won 45% of their basketball games. Well, let's say they played X basketball games. I don't know exactly how many games they played. They played X basketball games before the district play, right? X basketball games before the district play. They won 45% of that. So we have this ratio, X, and they won 0.45, right? If you're writing a percent as a decimal, it's very easy. You remove the percent sign and just move the decimal place over 2 times. So they won 0.4. This is our ratio so far. And this is equal to 1/2, right? But we're not done. We have to include the district play games. So during district play, they won 6 more games. So add that to the number of games that they won. And lost 2. So you add to the number of total games they played 6. They won 6 and lost 2. That's a total of 8 games. And now we have a ratio. Cross multiply. So multiply this times this and set it equal to this times this. That would give us 0.45x plus 6 times 2, and this is equal to x plus 8. Or 0.9x plus 12 is equal to x plus 8. What do we have? 4 is equal to 0.1x, so that x is equal to 40 games. And now you might be like, okay, they played 40 games, our answer is 40. And you would be wrong. Remember, they played 40 games before district play. It's important to specify what your variables mean. Here, x, and how you might do that during the test and not waste time is just highlight the portion of the problem where it says it. So x is before district play. During district play, they played 6 more games and lost 2 more. Okay, that would give us 40 plus 8, or 48 games in total. Okay. Well, now I think a lot of you people already saw this, but we're going to be having a special giveaway. So we'll be giving away 2 Wolfram Alpha notebook editions, and we'll probably be giving out other prizes too. So the notebook editions are valued at $50 each, and you can enter that by going to thepuzzler.com/AMC-8-bootcamp-giveaway. We'll give you about a minute or more to try and do that, and let me put the link as well in the live stream chat. So feel free to enter the giveaway. If you don't win this week, you can always win next week or the week after that. We have about 9 or 10 weeks to go, so you have a pretty good chance of winning a prize. Okay. I think that should be enough time to enter the giveaway. You can always still do that right now when you're paying attention to the class, or you can do that later, right? It's available on the course on our website, right? thepuzzler.com/courses/AMC-8. Okay, let's move to the second portion of our class. Distance is equal to speed times time problems. Now these problems, 3 things. You just need to know the distance, the speed, the time. If you don't know any one of these things, you can plug in the other 2 and figure out the third one. And that's what makes them really unique, right? If you only know the speed for something, you can't really figure out the distance that they traveled without knowing the time that they traveled. But if you know any 2 of these, you can figure out the third one. A common way to memorize these is the term dirt, right? Because D is equal to rate times time, right? So you could just write it as dirt to memorize it. That's one common way I've seen of memorizing it. But you just can memorize this formula. Distance is equal to speed times time. And using a bit of creativity, you can solve these problems. Let's just try a basic example of the formula. Jamal rides his bike at a uniform rate of 12 miles per hour for 4 hours. How much distance has he traveled? He traveled X miles, right? X, we don't know. And he traveled for 12 miles. He traveled at 12 miles per hour for 4 hours. 12 times 4. 12 times 4 is our answer. So 12 times 4 is just 48. So he traveled 48 miles. Usually on the AMC 8, you don't need units because they add it for you. But in practice, you do want to add some sort of unit, right? I might just write M instead of that ugly miles I wrote right there. But that's what you should do. There's another formula, right? If you divide both sides by time, you'll get the formula average speed is equal to distance over time. And this can be super useful because you just need to look at the total distance and the total time to find the average speed. So even though someone might have been traveling for maybe say 10 miles at 20 miles an hour and then traveling for the rest of the trip at 30 miles an hour, you could find their average speed using this formula. Okay, so John drove for 3 hours at a rate of 50 miles per hour and for 2 hours at 60 miles per hour. What was his average speed for the whole journey? And be careful, you'll get the wrong answer if you just add up the two speeds, 50 plus 60, and divide by 2. That's incorrect, right? You have to see how much time they traveled there, how much distance they traveled there, and that's how you would solve it. By the way, this problem and the last problem were not from the AMC 8. We'll be looking at distance equals rate times time problem from the AMC 8 soon. Okay, so for this problem, let's try figuring out the total distance that they traveled. At 3 hours for 50 miles per hour, you get 3 times 50. That's equal to 150 miles in total. So they drove for 150 miles at 3 hours, right? At the rate of 50 miles per hour. Then plugging 2 hours at 60 miles per hour, you get 2 times 60 gives you 120. And this gives us 270 as our answer. How many hours did they travel in total? 3 plus 2 gives us 5. So even though they didn't travel at different speeds, they did travel at different speeds. We can find the average speed by getting the total distance and the total speed, or the total time. And this would give us, let's see, 270 divided by 5. That gives us 520, so 54. 54 miles per hour. Okay. See, let's look at a speed paradox. What's the puzzler's channel without paradoxes? If I drive from Oxford to Cambridge at 40 miles per hour and then from Cambridge to Oxford at 60 miles per hour, what is my average speed for the whole journey? So now you might just think it's 50, but try to figure out what it is. The weird thing is that they don't tell you exactly what the distance is. But like I said, if you don't know something, either set a variable for it, or in a problem like this, if they haven't told you and they haven't given you any numbers about the exact distance, what can you do? You can assume the value. Okay. Let's just assume what this distance is. But better than that, let's assume it's just x. Okay, so the total distance that they traveled is 2x, right? They traveled 2x because x from Oxford to Cambridge and Cambridge to Oxford is another x. Now, if I drive from Oxford to Cambridge at 40 miles per hour, what is my distance going to be? Or what is my speed going to my time going to be, right? So x is equal to 40 times time, right? Or our time is equal to x over 40. Similarly, when we're going from Cambridge to Oxford, we get x is equal to 60 times time, or time is equal to x over 60. So what's our total time? It's x over 40 plus x over 60. Notice I'm not including units anywhere. We know that we're only talking about miles and hours, so it doesn't really matter. And once again, the value of x's cancels out. We're left with 2 over 1 over 40 plus 1 over 60. Well, 40 and 60 are both factors of 120, right? So we can get common denominators. We get 2 over 3 over 120 plus 2 over 120, which is 5 over 120. So our fraction is 2 over 5 over 120. 5 cancels out here. And what do we get? Oops, there should be a 0 here. What do we get? We get 1 over 24. Let's plug in 24 above there to get 2 over 1 over 24. And this gives us an answer of 48. And the way I solve that is 2 over 1 over 24 is the same as 2 times 24 over 1. Whenever you have a denominator in the denominator of a fraction, you can just take that to the top. Okay. Now let's look at AMC 8 problems. We'll start out with the problem number 11, and this is from the 2020 AMC 8, so a lot of you might have even taken this problem or solved this problem. After school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took a bus. The graph below shows their journeys, indicating the time and distance traveled. What was the difference in miles per hour between Naomi and Maya's average speed? So I'll give you a hint here, right? Remember that the time at the bottom is in minutes, and our answer is supposed to be in miles per hour. And you might have figured that out yourself if you actually took the test, because they gave you multiple choices, right? But when we're solving it without multiple choices, we have to make sure that we notice that. Okay, let's try solving this problem. We're running a bit low on time. We might go a bit overboard in the first class. So let's see. So Maya, she traveled what? She traveled 30 miles. No, she traveled 6 miles. She traveled 6 miles in 30 minutes. So she would travel how many miles in 1 hour? Well, you double 30 minutes to get 12 miles. Now Naomi, she drove 6 miles herself in 10 minutes. Well, if you multiply 10 minutes by 6, you would get 1 hour. And you do the same thing for the actual distance, which is 6 miles in 10 minutes. That would be 36 miles in 1 hour. 36 minus 12 gives us 24. So I used a bit of logic in that problem, but yes, you could have also set up some equations to try and solve this problem. Let's look at the next problem. Here's the problem number 16 from the 2019 AMC 8 test this time. King drives 15 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? Take a minute on this problem and see if you can solve it. Okay. Let's use our formula. Total distance over total time gives us the actual average speed. So we want the average speed to be 50 miles per hour. How much has he traveled? He's driven 15 miles plus what else has he driven? Well, we don't know how many hours he drove at 55 miles per hour, right? We need to figure that part out. So I'm just going to say there's X hours. Our answer is not going to be X though. We're trying to look for the number of additional miles. So that would be 55 miles per hour or 55 times X. What does this give us? This gives us 15 plus, what's the total distance? 55X. And what's the total time? Well, if she drove 15 miles at an average speed of 30 miles per hour, that means that it took her half an hour. So 1/2. Plus, we already said she travels for X more hours. So 1/2 plus X. And this should be equal to 50 miles per hour. Right? 50 miles per hour. So what do we do here? Let's multiply by X. We get 15, or let's multiply by 1/2 plus X. We get 15 plus 55X is equal to 50 times 1/2 plus X. We can divide both sides by 5 first to simplify. We get 3 plus 11X is equal to 10 times 1/2 plus X. And now we can distribute. 3 plus 11X equals 5 plus 10X. Okay, so what do we get here? We get X is equal to 2. I subtracted 10X from both sides and I subtracted 3 from both sides. Okay, so X is equal to 2. What is our answer? It's not 2. It's 2 times 55. 2 times 55 gives us 110. Okay, 110. We can plug this number back into the original problem to see if it works really quickly. We get 15 plus 55 times 2, which is 110. 110 plus 15 gives us 125. And then 1/2 plus what? 1/2 plus 2 is 2.5. And this should equal 50. Luckily for us, this is 40 plus 10, and it does equal 50. We can move on. We're running a bit low on time, but we only have a couple problems left. Here's a problem number 17, this time from the 2015 test. Jeremy's father drives him to school in rush hour traffic in 20 minutes. One day there is no traffic, so his father can drive him 18 miles per hour faster and gets him to school in 12 minutes. How far in miles is it to school? Okay, so this problem is a bit hard and it can't really be solved in 60 seconds, so we'll try solving it together. His father drives him to school in rush hour traffic in 20 minutes. So that means that whatever distance he travels, he can do that in 1/3 of an hour, right? If he travels X distance, he can do that in 1/3 of an hour. Whatever his speed is, it's 1/3 of that. And this is equal to, so 1/3 S times T. What is this equal to? Well, their speed. So the normal speed for school is okay, what is this T? So the normal speed for school is S. The traffic, or I mean the time for the school is T, right? Or that's 1/3 in this case. And notice I wrote 1/3 and not 20. Now what else do we have? We have that this is the same thing as him driving 18 miles per hour faster, S plus 18. And this would get him to school in 12 minutes. 12 minutes is just 1/5 of an hour, so this is 1/5. You could also do this in minutes, but I prefer to do it in hours so that we won't have to do any conversions. So we have S times 1/3, and this is equal to S plus 18 times 1/5. And we can figure out the value of S from here. Okay, so we have 1/3 S. Let's multiply both sides by 5 and 3, right? That way all fractions cancel out. So we're left with 5S. So that's supposed to be the variable S. Don't think that it's the number S, the number 5. So there's just 5S is equal to 3 times S, 3S, plus 3 times 18, which is 54. So no more fractions. We get 2S is equal to 57, or 54. and then s itself is equal to 27. So our speed is 27. And in rush hour traffic, that's 1/3 of an hour. 27 times 1/3 of an hour would give us the distance, which is 9. Let's just double check our answer. If his dad is traveling at 18 miles per hour, which is 27 plus 18, or 35 plus 10, or 45, and then he only needs 1/5 of an hour, is this equal to 9? Yes, it is. So our answer is correct. It's 9 miles to school. Okay. Oops. We have some numbers here. Let's erase that. I think this is our last problem for the day. 2014 AMC 8, problem number 17. George walks 1 mile to school. He leaves home at the same time each day, walks at a steady speed of 3 miles per hour, and arrives just as school begins. Today he was distracted by the pleasant weather and walked the first 1/2 mile at a speed of only 2 miles per hour. At how many miles per hour must George run the last 1/2 mile in order to arrive just as school begins? Our last problem, let me start your 60-second timer. By the way, make sure you try not to leave early, right? Because I'm going to be telling you how exactly you have to do the homework for this week if you want to do the homework. Okay, so for this problem, let's figure out how much time it usually takes him. He walks 1/3 mile to school, or 1 mile to school, in a rate of 3 hours per hour. So 1 mile is equal to 3 times time. So time is equal to 1/3 of an hour. Okay, so it usually takes him 1/3 of an hour to go to school, which is 20 minutes. I'll write that here, 20 minutes. And today he was distracted, so he walked the first 1/2 mile at a speed of only 2 miles per hour. Well, 1/2 mile at a speed of 2 miles per hour, that is 1/2 equals 2 times t, or t is equal to 1/4, which is 1/4 of an hour, or 15 minutes. So 15 minutes have already passed by, and he's only walked 1/2 mile, right? So he has to walk another 1/2 mile. Subtract 15 minutes from here, and he only has 5 minutes left right now. And he has to go 1/2 mile in 5 minutes. 1/2 mile in 5 minutes? Well, there's 12 5 minutes in an hour, right? So we multiply his speed, his 1/2 mile, by 12 to get 12 over 1/2 is equal to 6. So if he runs at 6 miles per hour, he'll arrive just as school begins today. And that is the answer to 2014 AMC 8, problem number 17. Okay then, thank you everyone for attending. Homework is actually going to be available at thepuzzler.com/AMC-8-bootcamp, and it must be done prior to next class. We do leave homework optional though, so if it's too hard for you, the problems are a bit challenging than what we did in class. So if it's too hard for you, you can always leave it, but rest assured, you can always ask for help on any of the questions. And the way you do that is just by commenting directly on this video. Are there any questions before we end the live stream? Any questions about anything? Any questions about the content that we covered? How we're going to access the course material? I'll give it about 30 seconds. If there's no questions, we'll go towards our conclusion. Okay then, so you'll find all the appropriate links in the video description of this video, And that also includes the link to the course and the homework. Okay. Thank you, everyone.
Thank you for watching this video. If you liked this video or learned anything from it, let me know by subscribing or commenting below. For more awesome content, check out thepuzzler.com. You'll find amazing articles and free courses there. Thank you.